Hello friends, welcome back to CIVILDEPTH-BD. Today I will show you how to define all types of dead load and live load and assign them in this structure. At first go to define, then go to load pattern. Under load, just write WL, that means wall load. Type will be super dead. Click on add new load. Then write PWL, that means partition wall load. Type and self weight multiplier will remain same. Click on add new load. Floor finish, that means the weight of the tiles. Click on add new load. Now here live load is already available, but for assigning the load of water, here I will define another live load pattern and I will name it as live load 2. Type will be live, then click on add new load. Click on OK. Now we have to understand what is wall load and what is partition wall load. Simply, the thing is the loads of wall which are acting directly on the beam will be considered as wall load, and the load of the walls which are acting on slab panels should be considered as partition wall load. So how to calculate the wall load? We have to calculate the wall load by unit weight of brick, height and thickness. Now what is the unit weight of brick? If you follow this book, which is BNBC 2020, in page number 554 of this PDF, here you can see that the unit weight of brick is 18.9 kilonewton per meter cube. Now we have to calculate the height and thickness from this drawing. Suppose if I go to ETABS, here I have taken the property of beam which is 12 by 18 inches. So below the beam, the height of the wall should be 8.5 inches because total height of each story here is 10 feet. If we subtract 18 inches, remaining value is 8.5 inches. And the thickness, here we are considering all the walls 5 inches. So how to calculate the wall load? Let me show you. 18.9, which is the unit weight of the brick, 18.9 should be multiplied by 8.5. This is in FPS units, so divide this value by 3.28, which is height. Unit weight of brick multiplied by height, then again multiply this with 5 inches. Okay, thickness of each brick is 5 inches, but by considering the plaster, here I will take 6 inches, that means 0.5 feet. Now divide this value by 3.28, okay, which is 7.46. But under each wall load or under each wall, there may have some opening for window or for the door. So here I will consider the 80% value of this 7.46, but for the staircase I will take full value. Okay, let me show you. Go to select object type, go to select beam, close. Now I will uncheck the values. I uncheck the beam for this staircase. Okay, for the roof we should not assign such higher value because there will not be any wall load. in most of the beam. Just for the periphery, we will assign around 3.5 kilonewton per meter load for the parapet wall. Okay. Now go to assign, then frame load, go to distributed, under wall load. Here, okay, we have to change the unit, metric SI unit. 80% of 7.46 should be around 6 kilonewton per meter load. So here I will assign 6 kilonewton per meter load. Now we have to select all the beam beside this staircase. So I will go to all stories, then select this beam and this beam. Similarly, here you can see for the top floor, we don't need any water tank bottom slab. Here it's fine. It should not be selected. It should not be selected. At first, I will work on these beams because here we don't need wall load at all. This is the bottom slab. This is the bottom slab, so it's okay. For the bottom slab, it's okay. But for the top slab, sorry, this one is bottom slab. For the bottom slab, it's okay. That means at this position, apology, for the bottom slab also, we don't need this 6 kilonewton per meter load because here we have already modeled the wall. So select this one, go to assign, then again frame load, distributed, wall load. Here this time I will assign 0 kilonewton per meter load, or we can go to delete existing load. Similarly, for the top floor, we don't need this load, so we can delete this load. Now come back to the staircase. This time I will select all stories. Again uncheck this value, uncheck this beam. From here I will select one story, uncheck this, uncheck this. Okay, hopefully this is fine for this time. Now go to assign, frame load, distributed, around 7.46 kilonewton per meter. So undeformed shape. Now we have to assign partition wall load. So the formula is unit weight of brick, volume of brick, and the area of the room. So we already know the unit weight of brick. Suppose for one panel, let me calculate. How to calculate the volume of brick wall? Here the length is 5 feet 1 inches, and for this side the dimension is 8.5 inches. Okay, 5.08 plus 8.42, that means 13.5 feet. Divide this one by 3.28, which is 4.11 meter. Now multiply this value by 10 feet. 10 feet divided by 3.28. Now multiply this with 6 inches. That means 0.5 feet divided by 3.28. okay, which is 1.91 meter cube. Now multiply this one with unit weight of brick, which is 18.9. As a result, here we are getting 36.15. Now we have to divide this value by the area of room. Okay, so here we can see, here I will take just the dimension randomly, which is 18 feet divided by, okay, 18 feet by 16 feet. Okay, so answer is 36.15. 18 divided by 3.28, 16 divided by 3.28, which is around 26.76. Now 36.15 divided by answer is 1.35 kilonewton per meter square. But as per the code, here you can see there have recommendations. Brick masonry work excluding plaster, unit weight per unit area. Weight per unit area is 1.91, and the weight of plaster, cement plaster per 10 mm thickness is 0.230 kilonewton per meter square. If we go as per the code, here we are getting 1.91 plus 2 into 0.230 equals around 2.37 kilonewton per meter square. That means if the calculated value is less than 2.37, I will recommend you to use the minimum value as per the code. Or if your calculated value is greater than 2.37, then go with that value. Okay. So here I will use 2.37 kilonewton per meter square load for these three panels. You can calculate them separately and check the values. Okay, here I will go with 2.37. This panel, and this panel. Okay, so go to all stories. Okay, let me check. There may have some variation by not taking. Okay, one story. This is for ground floor plan. Okay, and this one is for the typical floor plan. So at first I will go for the typical floor plan. All stories, this portion and this portion. Okay, these three portion here I will select, but we have to deselect roof panels. Okay, so go to roof. From the plan view I will go to roof, click on apply. We don't need this here. Also go to the ground floor plan, or we can say story 2 maybe. Yes. Okay, now go to assign, then go to shell load. This time go to shell load, go to uniform, then select partition wall load and assign here 2.37 kilonewton per meter square load. Okay. Now we have to assign floor finish. So go to select object type, then go to shell or floors, select floors. Now we have to go to the roof. Here we will assign some different load. So I will deselect this one, this panels actually. Okay. Now we can assign load, which is around 1.20 for the normal clay tiles. Okay. And for the roof, we will use terracotta type tiles. That means for roof, we will assign 1.43 kilonewton per meter square load. So go to assign, then go to shell load, uniform, floor finish 1.20. Click on apply. Okay. Maybe here you can see the values. Fine. Then go to roof. Click on apply. Okay. Select all the panels. And here I will assign shell load uniform 1.43 kilonewton per meter square. Okay. Now we have to assign live load. For residential building, we will use 2 kilonewton per meter square if you are designing a structure which is with 2 unit per floor. But for stair and balcony, we have to assign a separate type of load. Okay. So what will I do? At first I will click on show undeformed shape. Then go to select object type, floor, select close. Then I will go to roof, because for roof we have to assign different load. Okay. For other floor, here I will assign. Okay, we will not. Here also I will use for some different load. Okay, we can assign 2 kilonewton per meter square load because this is a building with 2 unit only. So go to assign shell load uniform under live load. Here I will use 2 kilonewton per meter square. Okay. Similarly, I will select waste slab. Go to select properties, slab section, waste slab. Click on select, close, assign shell load uniform 2 kilonewton per meter square live load. Similarly, we have to assign floor finish in waste slab. So click on previous selection. From the drop down menu, select floor finish, and here input 1.2 kilonewton per meter square load. Click on OK. Go to any one, then go check the loading values. This is OK. Now for roof, we have to define another load pattern. Go to define, then go to load pattern, live load 3, we can name it. Go to live, click on add new load, click on OK. So this time I will go to roof. This is for finish, right? Now we will select all the panels here by considering the gardening, here I will use 4.80 kilonewton per meter square load actually. Okay, gardening is very common in this time. So I will go to assign shell load, then uniform, which is life 3 or LR, you can say. I will use here 4.80 kilonewton per meter square load. Now we have to assign load for water. So here I will consider this one. Go to define section property, slab section, water tank, modify. We don't need this one way. Consider this one as shell. Okay, consider this one as shell. Now, how to find out the uniformly distributed load for the water? Here, how to find this? Here you can see that this one is at 20. Okay, go to edit storage and grid system, modify / show story data. Height of water tank is 1.8288 meter. Okay, so unit weight of water, we can say 9.8 into 1.8288. This is around 18 kilonewton, 18 kilonewton per meter square. Okay, so click on OK. So select this one, then go to assign, then go to shell load uniform, select life 2, which is 18 kilonewton per meter square. Okay. So what we have assigned? At first we have assigned wall load, then partition wall load, then floor finish, roof live load, load for the water. I hope we have completed assigning all types of load. You can check these values. Go to display, load assigns, frame. Under frame, we have assigned wall load. We can see. Then we have assigned all other values under shell. So go to display, then go to load assign, click shell. At first we can see dead load, which is the self weight of the panels. Then go to live load. We have assigned 2. Somewhere we have assigned live 2, which is this one 18, and live 3 for roof. Then check partition wall load also, which is 2.37 excluding the roof. That means today we have completed assigning all types of dead load and live load in this structure. That's all for today. See you in the next tutorial. Thank you.